So the other day I had 20, 60, da-da-da-da-da-da-da. So I'm going to read some answers real quick. I've got kind of a little complex information delivered today, so I want to make sure I'm not squeezed for time. 60, 60, 60, 60. And of course, well, here's the answers to 60. I'll just kind of put this up here. Okay, you got that graph. Your domain is from 0 to 11. Range is from negative 0.3 to 1.04. 60 part C. The y-intercept looks like it's about 1.04. No, hold on. That's not right. 60C. Negative 1.04? Oh. The y-intercept? Y-intercept is 1.04. 60D. Any zeros, about 1.5 and 5.2. And the zeros represent the months the stock price returned to its original value. We'll come back at anything that you want to take a look at. 89's odd. 107, 108. 108 is J. And 110 is F. Honestly, especially for you guys, I think these problems are incredibly important. Why? You guys are taking your ACT later on this year. Don't ignore these problems. Don't just look in the back. Do them. Try and do them well. Whenever you do an ACT, your goal is to do two things. Get it right.
Do it quick.
And do it quickly.
Yes.
Exactly. Probably more right than quickly, but because that's so these. I love this textbook because they give these to us every section. So there's no reason we can't have our ACT review just be seamless every section, and we get some practice, get some practice, get some practice.
Is there any certain sections on the ACT? Does that make sense? Or is it should be everything?
It's everything.
It's just everything.
It's everything. Yep. And what's interesting is there's 60 problems on the math part. It's all multiple choice. And to get the state average of 21, which you guys shouldn't get the state average of 21. You guys should blow that away. But anyway, all you have to do is get half of them right. So for you guys, if you're ever practicing, practice the first half a couple times. But you guys probably need to spend, if there's problems 0 through 60, you probably need to spend more time on problems like 20 through 50, 30 through 60, something like that. Okay? So that's just my advice from my 72 years of teaching experience.
When's our coming up test?
Right back here. It's probably next Wednesday or Thursday. Okay? 60 on page 30. 68. And of course they don't have it back there. 68 is actually and neither. 70. The domain is from negative infinity to negative 2, not including negative 2. Negative 2 to negative 1, not including either one of those. And also from negative 1 to infinity. 72. The domain is from negative square root of 2 to positive square root of 2. 80 is D. 82 is 85,140. Okay, I don't want to spend a ton of time on that, but if you guys have a question that you'd like me to take a look at from some of that, I'd gladly go over it. I just, last thing I'm going to do is all of them. Anything, especially the ACT stuff, that's good stuff to take a look at.
110 roll. 110?
Let's take a quick gander at 110. Oh, you know what? And that's the information from this stuff, so it's not a bad thing to look at here real quick. I'll get out of the light. Domain. So on this one, I don't care about the top. The bottom. The bottom can't be 0, so the bottom can't be 0 or 16. How do I know that? I just took out an X. So if you set the bottom equal to 0, you get x times the quantity x minus 16. So you get 0 and 16. So it's everything but 0 and 16. So it's F. Because by doing this, they skipped 0. And by doing this, they skipped 16. And that problem, with some experience, how long should that problem take you on the ACT?
Not very long.
Yeah, 15 seconds? Yeah, that was 10 right there. So yeah, I think a person could. So, okay. What'd you say, Gigi? X minus 4 something?
No, yeah, I was like,
Oh.
I was thinking during the ACT because I was so nervous.
Yeah. Well, it's one of those deals. Okay, nervousness. What you have to do is just prepare well, and then I'm convinced that nerves is a result of the fact that you care about the results, but you just can't let your nerves get in the way of a good performance, which that's tough, and that comes from practice tests and stuff like that. Okay, anything else you want to take a look at real quick? Tomorrow, no homework. Why? Long weekend. So here we go. Get ready for new info. We're still dealing with section 1.3, I believe. Yeah. This is a little bit higher conceptual value. This is dealing with laying some groundwork for calculus. So let's go ahead and get ready. First thing we're going to do is we're going to talk about continuity. I don't know about your Algebra 2 class if you talked about continuity or not. You guys learned out of a different Algebra 2 book than I'm teaching out of currently. We've changed textbooks, so I apologize. I don't even have access to the old textbook to look back into it. So continuity. I'm just going to draw some pictures, and you're going to tell me what your gut says about continuity. Okay? Does that graph appear to be continuous? Yeah, it's continuous. Okay, let's go to the next one. What about that one? Is that continuous? Not all of it's continuous.
Most, I think the bottom half. But
What's interesting about continuity is there are parts where it's continuous and there are parts where it's not. Okay? So like if I'm going through here, yes, it's continuous, 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 but from here to here is this continuous? Oh no. So the way that it's defined in my Algebra 2 textbook is very, very basic. Can you draw it without lifting your pen or pencil? This part, yes. This part, yes. The whole thing, no. So as far as the whole graph, that is not continuous. Okay? Now let's go to the next one. What do you think about that one? Is it continuous? Is it continuous everywhere?
no.
It did. But what's interesting, what is your name again? I forget. Bryce. Bryce brings up, he like says, well, because something, 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 we're going to have a test by the end of the period that we have 3 different things that's got to be true for it to be continuous. Okay? And we'll look at that here real quick. We're just laying the ground for continuity. So here is it continuous? What do you think? Is it continuous here?
Yeah.
Yeah, what about here? What about right here? No, Okay. So this would be no, not everywhere. Well, this one, I had to pick up my pencil. Okay. Is that one continuous?
No.
No, obviously not. Okay. So I want you to realize that, what continuity in the general idea is. And there's three different types, or there's there's three different types of discontinuity. Okay? This is not, it's what's called an infinite discontinuity. An infinite discontinuity. Why? Because at some point in time, it just goes infinite and then infinite on the other side. Okay? This one has, let's just go over here. This one is probably the easiest. This one has a jump discontinuity. Well, I think the term makes sense, doesn't it? Because it jumps from one value to the next. Okay? And then this one actually has what's called a removable. Because what could I do with my pen to remove that discontinuity? Color it in. Okay? Or, in terms of function-wise, what could I do to remove that discontinuity? Is I would define the value of that function at that point. Okay? I can't change like where this goes very easily, but I could just say, you know what? At 1, my result is 1. If I add that definition to my function, that for whatever reason had a hole there, I just removed the discontinuity. Okay? So we'll talk about that a little bit later on, but again, we're trying to lay the groundwork for some terminology you'll need a little bit later on. Okay? So here's the deal. We need to be able to test for continuity rather than just say it's continuous or not continuous. So here we go. The three conditions for continuity. One. Yeah, I'm sorry. Thank you. I've even got this right here. I'll blow this up so it's a little bit more in my vision. Three conditions for continuity. 1. Let's go continuity at x equals c. At some value of c. 1. F of c exists. Another way to say it is you could say f of x is defined at c. That's another way to say the same thing.
So what is the x equals c for?
Because this right, because I'm saying at x equals c because we're not talking about whether, well, if we go back up to here, we talked here about it's continuous here, but now we're talking about if it's continuous at a certain point in the graph. Like on this one right here, it's continuous right there. But we're going to talk about being continuous here. Okay? So there are parts that are continuous, parts that are not. Okay? 2. F of x approaches the same value. I always forget whether, okay. The same value from either side of C.
Do you like to write like all caps?
Yeah, you don't want to see my lowercase. And I know you don't want to see my uppercase either, but I'm trying to do better.
No, it's not bad.
Yep. Yeah, well, I don't know. It is what it is. Now, another way to say this is that the limit of, as x approaches c, of f of x exists. And I would like to write in pen so it's dark enough you can see it. So that's why I scribble every once in a while, because I can't erase. It exists. Have you ever seen the term limit before? Okay, I didn't think so. So then what the limit is what is it getting closer and closer and closer to? Okay, what is it getting closer and closer and closer to? So like if I was going to clarify this with a graph, you don't draw this particular deal here. Let's say if I was going to go right here and I'm taking a look at C, well then this is f of C, f of C. Okay? So here's what it's saying. F of x approaches the same value from either side of C. So if I'm coming from this side, I'm getting closer and closer and closer to that height. As I'm coming from this side, I'm also getting closer and closer and closer to that height, that result. So from the right side or the left side, I'm getting closer and closer and closer to the same value. Okay? So let's stop right here and let's look at the four graphs we have up top and see which ones are violated. Okay? First one, f of c exists. So if I would say my c is right here and my c is right here, 0. Does f of c exist?
Yeah.
Do I have a point there?
Yeah.
Well, no, I got an open circle there. So f of c doesn't exist. Nope, there's no answer there. F of 0. What's f of 0? Yeah, but what's my height? Nothing. There isn't one. Okay? At C, there's no one given unique value. Okay? Next one. F of x approaches the same value from either side of C. Which type of discontinuity violates that? We have three different types, or two different types. Infinite or jump. Jump. So here, as I approach it from the top, it's getting closer to that value. Here, as I approach it from the bottom, I'm getting closer to that value. Are those two values the same? They're not. Now, here's what they say. The limit exists. Let's define what a limit really kind of is. You know, in kind of layman's terms. You know, just introductory terms. You guys know with your graphing calculators, you can zoom in and zoom in and zoom in and zoom in and zoom in, right? Well, like on this part right here, let's say this point right here. If I would zoom in, I'm going to draw some pictures up top, it would look like this. Right? If I'd zoom in some more, it would look like this, right? And as tight as I can zoom in around that point, I'm still going to have my graph approaching that same point. Okay? Is that the case here? Could I zoom in on just one point and have my graph touching both sides? No. This one, it's weird, but that limit exists. It's weird, okay? Because it's still going to the same point. But that's a whole nother ballgame for a whole nother deal. And then, last one, 3. The limit, as x approaches c of f of x, is the same value as c. I'm sorry. F of c. So what that's saying is, oh geez, I almost tripped on the carpet. That would have been real smooth. How'd you get those stitches? Well, I tripped on what? The carpet. Okay. So you don't care about my well-being. You just care about not having homework. Wow. Okay. That's good. That's nice. I love you guys too. Yeah, I'm glad I'm here at West Point Public Schools as well. Okay, good. Okay, so what this is saying is this height is the same as my height that it was approaching. It's going to seem like, well, like duh. And picture this. If I'm talking about this point right here, there's f of c. What's it getting closer to? Well, that value. The only way I could do this is if I had this and this point up here. This is f of c. Is my limit, is it getting closer and closer and closer to that height? No. So that's kind of an abstract thing. This whole thing is kind of abstract. If your brain's going, what the heck? It probably should for a little bit. Okay? So what we have to do is we're going to do an example here. We're going to go through all three phases, and we're going to see if a function is continuous at a certain point. Excuse me. So here we go. We're going to do a problem from the textbook. I have chosen number 3 in class. So we're going.
What page?
Well, this is page 30. I'll write it up here. No. That's just an example here. So I've got f of x. Well, they said h, but I'm going to use f. I'm a rebel. I want to see, is this continuous at x equals 6 and at x equals negative 6? I'm curious. Is it continuous at those points? So number 1, we're going to do both these. What is f of 6 and what is f of negative 6? Ladies, find f of 6. Guys, find f of negative 6. Go. Go. Yeah, you don't need your calculator, Sam. Thanks, Bryce. Okay. So, ladies, what'd you get for 6? 0. So here's the deal. What is the test? It says f of c exists. So yours passes test 1. It exists. Okay? It's got to pass all 3, though. Okay? Guys, what is f of negative 6? What is it? 0?
So like undefined.
It's undefined. Because I get 0 on the bottom. Don't tell me that you think divided by 0 is okay. It's not okay. We can't ever, ever, ever divide by 0. Nobody can divide by 0. Not even Chuck Norris can divide by 0. Yeah, exactly. That's what I was thinking. Okay? So this one is undefined because we end up with a divided by 0. So right here, does this pass test 1? No, it doesn't exist. So we're saying it's not continuous at negative 6 on that one. So let's just do the other ones. What is it's asking for, what is the limit as x approaches either side of c? Well, in this particular case, I'll tell you what, let's do this. Let's keep you guys working here. I'm just curious, what is f of 5.9 and what is f of 6.1? Okay. Ladies, 5.9. Guys, 6.1. Go. You will need your calculator on this one.
Get your calculator out. Yeah.
say for that?
Oh, I know what it is.
Okay. If it's on the class then. No, you have 30 seconds.
Wait, what?
No, that's what Gigi got. Square it? You put it in parentheses? You guys square it? With parentheses? That's the
Okay.
What'd you get?
Please tell me you guys are agreeing on this. Ladies, what did you get for 5.9? Negative 0.1? Yep, I agree. Guys, what'd you get 6.1? Well, you're obviously wrong. Be quiet.
What? How am I?
I'm the closest.
So I'm not going to take the time to re-demonstrate how to plug in 6.1 into that equation and get the right thing. But what probably happened was you need to put parentheses around the bottom. If you did the top and then hit divided by, you need to have parentheses around the top and parentheses around the bottom. Okay. We'll forgive you this time. So here's the deal. Let's refocus on what we're doing. So at negative 5.9, it's negative 0.1. At 6.1, it's 0.1. Does it seem like what does it seem like it's getting closer to? It's getting closer to 0. So the limit as x approaches 6 of that function appears to be 0. And if you're not quite sure, what you can do is you can take advantage of our graphing calculator skills that we worked on the other day, and we can say, well, I typed in y equals, I set up my table, and then I went ahead and looked at my table here, and it looks like from both sides it's getting closer and closer and closer to 0. So it does pass. Why? Because they both go to the same value. So for 3, the limit as x approaches 6 of f of x is 0, which is the same thing as f of 6. So it's continuous at that point. Should we even continue with the test on negative 6? No, because we know it's not continuous. I'll show you what happens at that point. If I go negative 6, and then I look at that, look at my table. Here's negative 6. Okay, let me get out of the light here. Okay. There's negative 6. It looks like it's getting closer to negative 12. It is getting closer to negative 12, but it's not defined at negative 6, so it's done. Okay. You'll notice that if we graph this, it is a line. So this is a removable discontinuity because it just has a hole. Where does it have a hole? Negative 6. It's discontinuity. It's discontinuous at negative 6. Okay? So, okay. What else did I want to do? Okay. What time are we forced to leave here? 7 to 20. I still have some information I need to get through. I'll just show this. The intermediate value theorem. We need to focus. No. F of x is continuous function if a is less than b, and there's a value n such that n is between f of a and f of b, then there is some number c such that a is less than c is less than b, and f of c is equal to n. So here's the thing. Let me clarify. Honestly, one thing you've got to get better at as you continue to grow mathematically is better at figuring some of these things out from reading. But right now, you're going to need support. So that's fine. Okay? Here it is. It says I've got some value A and B, some values A and B. Okay, and I'm going to go ahead and say, here's my function. It goes something like this. Okay. So here's the situation. It says that n is between f of A and f of B. So there's some value n. It's saying that there is some value C somewhere in here that if I plug it in, I get this value n. Would you agree with that? That there's some value C between A and B where f of C does give me that result. Yes. I look at this as a very, very, very simplistic thing. Okay? If I'm over here and I'm going over to here and this is a river, I can't cross the river without getting wet between the two. Why? Because to get from here to there, I'm going to have to cross every single point on here somewhere. Oh, you'll impress me here. If the function is continuous. If the function wasn't continuous, it wouldn't make a hill of beans because it could jump all over the place. Okay? And a great way to look at this too is if you're driving a car and at let's say after 5 seconds and 10 seconds, let's say you're in a drag race or something, of course, on a sanctioned event, okay? And here you were going, at 5 seconds, you were going 20 miles per hour, and up here you were going 60 miles per hour. Then at some point in time, were you going 40 miles an hour? Yeah, at some point in time, were you going 37 miles an hour? At some point in time, were you going 59 miles an hour? Yes. Okay? So, most likely it would probably look something like this. But anyway, that's what's called the intermediate value theorem. And how are we going to use the intermediate value theorem? Well, here we go. If we had a graph that goes like this, and I said, at this value of x, let's say at 5, my result was -1. And at 6, my result was 3. Then what happens somewhere between 5 and 6? It crosses the x-axis and gives us what's called a 0, or an x-intercept. So if you're looking at a table of values, and I went from -1, then all the way up to 3, what conclusion can I make? There's an x-intercept or there's a 0 somewhere between. So for example, if I'm looking at this table of values, don't look at the graph. Okay, I'll zoom in here so you can... Okay? Where are there zeros or x-intercepts? Between what values of x? Between -3 and -2? I agree. Because it goes from below the x-axis to the above the x-axis. Can't cross the river without getting wet. Somewhere we had to hit the x-axis. So there's a 0 between -3 and -2. Okay, where else? 0 and 1. Where else? Between 1 and 2. There's my graph. Lo and behold, yes, that's where my zeros are. Could you guys, with your calculator, put that in and make a table? Yeah. Use your technology. Make your life easy. And I think I better stop there. I had one more thing I wanted to talk about, but we're stopping right there. And tomorrow, no homework. what we'll do is we'll come in, ask any questions we have about this, and then we will have this little activity. Here's what we got. Page 30. I just did one of the problems I didn't want to do in class. Well, what am I thinking? That was silly. 1, 7, 9. So on those, you're going to have to go through and do the 3 tests of continuity and decide if it's continuous there. Look back at the example in the book. They outline it really well. 15, 17, 25, 27. And you know what? 25 and 27, we haven't talked about that yet. But I want you to do your best on 25, 27. I'm going to write the rest down real quick. 35, 37. So these, consider those. I want you to, what the heck? Especially 25, 27. See how you can do with those. 35, 37, we might have to discuss a little bit. Not too bad once you guys got focused. This is a class that, boy, if we have 1 or 2 extra minutes, it might make all the difference in the world. So come on in, get focused, check stuff, and then we'll go from there.